All right, so yesterday we started talking about scatter plots and what they look like and what they can tell us and all that good stuff. So here's one. It's talking about our time with shoes versus our time without shoes. I don't know what we're doing, but I'm going to assume maybe running. I don't know. So what direction would you say that scatter plot has? Positive, right? It looks like it's increasing. So it's positive. What about its form? These are those words we talked about yesterday. It's linear. It looks like a line. Okay. And so if we sketched a line through it, it might look something like that. What about its strength? Yeah, I think I'd probably call this one pretty strong, right? I mean, everything's pretty much clumped right there together around that line, so I'd probably call that one strong. And do you think you have any outliers? Yeah, I think there's probably two. I think these 2 points are probably a little too far away from the rest of the data because everything else seems to kind of hug that line. So we have 2 outliers. They would occur maybe at about 8.5, 5.5, and then maybe 10.5, 8 maybe. It's kind of hard to read without grids on there. All right, so remember we'll always mark what they represent if we can on those outliers. But yeah, I think those are our 2 outliers that we have. Okay, so we're going to talk today about how strong is that linear relationship, okay, so that we can actually get a good feel for strong, moderate, and weak. There's a measure that we use referred to as correlation, okay? And so we're going to talk today about how to estimate correlation. It's a numerical value. We're going to interpret it. Does it mean it's strong, weak, or moderate? And then talk about the difference between correlation and what we refer to as causation. All right, correlation and then causation. So just 2 kind of different vocab words we'll look at there. All right, so let's jump in here. All right, and it asks, can you guess the correlation? And so it tells me that correlation, and they call it R, that's the number or the letter that they give for correlation, all right, is the letter R. And it measures the strength of the linear relationship. Oh. Okay, fat hand got in the way. All right, so the strength of the linear relationship between 2 numerical variables, okay? How strong is that linear relationship in my scatter plot, okay? It goes on to tell me that it falls somewhere between -1 and +1, okay? So this R number that we're going to get is going to fall somewhere between -1 and +1. What do you think a correlation of +1 would mean? Anybody know? Or remember from Algebra 2? Because I'm pretty sure you talked about it in Algebra 2, but it's been a hot minute. Maybe Algebra 1. I can't remember. Hey, bud. Good. Thanks. Okay. So because correlation falls between -1 and +1, +1 is going to be a perfect line. -1 is going to be a perfect line. Okay. What direction do you think it goes if it has positive correlation? Or if it has a positive number, do you think what kind of slope? Yeah, it increases, it goes up. If it has a negative correlation, guess what kind of slope it's got? Negative, it's going to go down. All right. So if 1 and -1 are perfect, what do you think 0 is? It's probably a curve, right? That means it's not a line at all. Okay. So 0 would mean that it's not a line at all. Okay, so that's what 0 would mean to us. All right, so what we're going to do is we're going to take these 3 pictures and we are going to try to guess what our number we think it would be. It's probably going to be a decimal unless one of these is perfectly aligned. Okay, and we're just going to kind of guess. Where does it fall? If it's positive, is it going to be closer to 1 or closer to 0? All right. If it's negative, closer to -1 or closer to 0, we're just going to guess, all right? And then we're going to use our applet to actually figure out the actual value here in just a second, all right? So let's take a look at this first set of data that we have, okay? Does it look super linear? No, okay? So I would say this one's going to be closer to 0. Will it be on the positive or the negative side? It's going to be on the positive side, and we know that it's a pretty weak relationship, okay? And so let's guess a decimal number. What do you want to guess? Something between 0 and 1 that might not be very good. Okay, 0.3. Anybody else got something else? 0.2. We might could even say something as far as 0.5, right? So just kind of halfway in the middle there. All right, doesn't look a ton like a line, but it might. Okay, let's look at the next one. All right, just guessing. Okay, what about this one? Positive or negative? Definitely negative. Weak or strong? Very strong. I'd say this one's very strong. Okay, so we know my correlation needs to be a negative. What decimal number might get me pretty close to -1? Yeah, I think 0.9 is a good guess. All right, we might could have even said 0.99, right? Because it looks pretty darn close to perfect. Okay, so just guessing. All right. And then let's look at this last one and see if it changes how I feel about any of the other two. Okay, so look at this last one. All right. Positive or negative? Yeah, I can't really tell. Okay, I really can't tell on this one, so I'm just going to put a big question mark there because it's just kind of all over the place, right? So what kind of correlation might you say? Weak, moderate, strong, very strong? I'd say this one's definitely weak and probably really, really close to 0. Yeah, I wish there was a very weak because it would be, right? Yeah, I think it's very weak, really close to 0. So that might make me think maybe this one is more moderate than weak because that last one is definitely weak, right? If we look at the comparison. And so I might change this number to 0.5 because it's a little better than the bottom one. Okay, so just guessing. All right, just guessing. So I did run a report on these, and I will tell you their actual correlation coefficients. So you ready? Here's the actual data. Okay. This one, R is equal to 0.551. So that guess of 0.5, anywhere from 0.3 to 0.5 was a good guess. Okay. This one, the actual correlation value, R was equal to negative 0.97. All right, so it was really good. And this last one, okay, we wanted to call it 0, but the actual correlation coefficient was negative 0.274. So it was really close down there at the bottom, all right, at 0.2. Okay. So now what's nice about this is that it kind of gives us a way to look at correlation, all right? We're not going to have to calculate the correlation coefficient today. We're just going to have to kind of look at some data and decide which one's the best pick, all right? And so when we think back to our learning targets for today, estimating it, talking about what it means, all right? So this is a negative, very strong relationship. The top one is a positive, moderate relationship. The bottom one, it actually came out to be negative. That was hard to tell from the picture, right? But it was a negative, weak relationship. So we're going to describe our data from that R number, okay? That's what we're going to do. Now, if you'll flip it on over to the back side, we're going to look through some examples and just kind of organize our thoughts on correlation. Tomorrow we'll do a little bit more with correlation, which should help us, okay? So let's start here. Learning target 1, all right, is just correlation. And I'm going to give you a chart here that I think will help you a little bit, okay? So we're going to start with kind of like a number line, all right? -1 to +1, and then we've got 0. And I'm going to put some 0.5s in there. Okay, so 0.5 and a negative 0.5. Okay. And so if it's to the right, we're going to call it positive. If it's to the left, we're going to call it negative, which is obvious if I look at the number. Okay. If it's 1 or -1, we're going to call it very strong. Okay. So it's got to be pretty darn close to perfect for us to call it very strong. All right. In between that 0.5 and 1, we're going to kind of call that strong. Guess what we call it when we hit 0.5? Moderate. Okay. Once we hit the 0.5s, we're going to call it moderate. All right. And makes sense because 0.5 is in the middle. Okay. And then the closer, bless you, and then the closer we get to 0, we'll call it weak. Okay. So just to help you with those words when we're looking at the numbers of correlation, I'm going to show you one of those here in just a second. Okay. Right. If they ask me to interpret, all right, here's what we're going to say. It's kind of like a sentence, and we're going to plug in certain things. Okay. R equal to, and we'll have that number, okay, so that'll be the drop down that we'll see. R equal to indicates the linear relationship is, and we're going to have two blanks here, blank and blank. Okay, in one of those blanks, we're going to put the direction. Okay, is it positive or negative? And in the other blank, we're going to put the strength. So those are the two words that we're going to use, positive or negative, strong, very strong, moderate, weak. All right, so really no different than what we did yesterday, except we're going to look at a numerical value instead of just a graph. Okay. So if they ask you to interpret, this is kind of the two words that we're going to use, all right? That R value is going to tell me if my linear relationship is positive or negative. That's my direction. And then is it strong, moderate, weak, or very strong? Okay. And then my third learning target has a new word in it, okay? It's the word called causation, right? And causation means, does one variable make the other variable happen, okay? So does one variable make the other variable happen? Does one variable make the other variable happen? All right, that's what causation refers to, okay? Now, correlation, if we look at a set of data and we see that it's linear, right, that does not necessarily mean that my two variables caused each other. For example, let's say, just for instance, we collected data from a specific group of people about their ACT score and their t-shirt size. All right, is there really any relationship between their ACT score and their t-shirt size? No, but it could be that we got the right group of people, all right, so that as their ACT score went up, so did their t-shirt size. Or as their ACT score went down, so did their t-shirt size. So we might actually see a linear pattern in the data, but do they cause each other to happen? No. Okay, and so that's the difference between correlation and causation. We'll look at one in just a second. So one of the things that we say about this is that correlation, helps if you turn your pen on this more. Correlation, I actually want to use a different color. Does not equal causation. Okay, so just because there's a linear relationship doesn't mean that those two variables cause each other to happen. Okay, so correlation does not equal causation. Right? So let me show you what our examples are going to look like today. We're probably going to finish the lesson before lunch today. So, all right, because it's really short, sweet, and to the point. Okay. All right. Okay. So now, I like this. It says, if I eat more chocolate, will I win a Nobel Prize? I wish. Okay? Because your girl up here can eat some chocolate. All right? It says, most people love chocolate for its great taste, but does it also make you smarter? Up for discussion. A scatter plot like this one recently appeared in the New England Journal of Medicine. Each point on the scatter plot represents a country, so we can see all the countries over there. The response variable is the number of Nobel Prizes per 10 million residents of that country. Okay, so let's look right here. Where's the United States? Where are we at? There we are. We're right here. Okay. So if we consumed a little more than 5 kilograms per year per resident of chocolate, and we've had about 11, looks like Nobel Prize winners. Okay. Who's eaten the most chocolate and got the most prizes? Switzerland. Okay. Makes sense. Swiss chocolate. They'd be eating the most, right? Okay. So it asked me to interpret the correlation of 0.791. So here's what we're going to say. Okay. That linear relationship is, first word, is it positive or negative? It's positive. I got a positive number. It's positive. And the next thing we describe is its strength. Okay. Moderate's more around 0.5, so 0.7 we'd probably call strong, okay? We want it to be as close to 1 as possible if we're going to say very strong in that 0.7, all right? It's almost 0.8 at 0.791, right? I'd say that's strong, all right? So there we go, all right? So the linear relationship is positive and strong. That's the only 2 words it's asking me for, okay? Positive and strong. Right? Let's look at number 2. It says, if people in the United States starting eating more chocolate, can we expect more Nobel Prizes to be awarded to us? No. Okay? One, that don't make sense, right? But the main reason why is there a linear pattern in our data? Yeah. But does eating chocolate cause me to be smarter? No. Okay? We would say no because correlation does not, Quinn, you have mail, does not mean that we have causation. Sorry. Okay, and we would just say correlation does not equal causation. That's all we're expected to say. Okay, just because there's a linear relationship, eating more chocolate will not guarantee I'm going to get a Nobel Prize, all right, or that I'm going to get more. I might luck up and get one, all right? That would be luck. It would not be because I ate chocolate, although chocolate would be yummy. Okay, are there any non-chocolate fans in the house? Like chocolate is a no-go for you. That's Coach Fretch. He will not. If you give him M&Ms, he won't eat them. You give him Skittles, he'll eat them all. Yeah, so just know that. He doesn't like chocolate. All right? All right, let's switch over and look at a couple more examples. And then we're going to be done. Okay? So this one, I just wanted to show you some pictures. Okay? I just wanted to show you some pictures. Here we have a correlation of 0. Can't really tell if it's positive or negative. They're just kind of all over the place. The second one is a negative 0.3. All right? So it's weak, but it does still appear to be negative. Here at 0.5, it's positive. You can tell it's meant to be linear, so we call it moderate, okay? This one, negative 0.7. Notice how the data's getting closer together, all right? It's negative, it's going down, so it's a little bit stronger. At 0.9, that's strong, all right? That's strong, and it's positive. And then here at negative 0.99, it almost looks like a perfect line, okay? So just seeing the difference, I wanted you to have some references to look at when you're looking at the numbers. So let's look at these two. Okay, so for each of the following, all right, is R greater than 0? What does that mean? Positive. Yeah, is it positive? Oh, God, y'all. Okay, so it's asking me, is it positive Or is it less than 0? Is it negative? Okay, so that's what it's asking me to answer. Okay, and is it closer to 0 or closer to the ones on that side? Okay, so that's all it's asking me. Closer to 0 or closer to 1. So let's look at the first one. Probably talking about cars there, miles driven and what the car's value is. All right, don't know for sure because it didn't tell me. All right, in that first one, is my correlation coefficient going to be positive or negative? It's going to be negative. Okay, it's going to be negative. Do you think it's going to be closer to -1 or closer to 0? Yeah, it's got to be closer to -1 because I can really tell that's a line. Okay, like that looks like a pretty decent line. So we're going to say closer to -1. So these are the kind of questions they're going to ask you today. They're not super tough. You're just looking at the numbers and the data. Okay, what about the next one? All right, positive or negative? Positive. Okay, it is going up, but my dots are a little bit all over the place. All right, what do you think this one's going to be closer to?
0.
Probably closer to 0, okay? My guess is it's actually probably close to 0.5. Yeah, I'm going to, you know, they didn't give me that as an option, but I really think it'll be close to 0.5. Okay, because it's not as weak as some of the other ones, but, you know, it's not great. All right. All right, let's look at this one. Okay, so everybody get what we're doing today? Just kind of continuation of yesterday, but looking at those numbers. All right, so let's look at this one. So here's a scatter plot. Weight of students from a weight training class that can squat and bench press. The correlation coefficient is, so they give it to me, R is 0.939. It tells me to interpret it. What are the two words I got to say? Yep, I got to tell you, is it positive or negative? So which one is it? It's positive. And then I got to describe its strength. At 0.9, what would you call it? Strong. Okay, that's the two words it's looking for. Okay, so every number wants two words. All right, and then last one. Okay. Says here's a scatter plot showing the relationship, and I think this is interesting, between total revenue generated by skiing facilities in the U.S. and the number of people who died by becoming tangled in their bed sheets. Okay. Strange comparison. All right. It tells me that the correlation is 0.97, which would mean it is positive and it is also strong, right? But now let me ask you a question. Does how much money the ski resort makes have any influence on how many people are going to die from suffocating themselves in the bed sheets? No, okay? They have no relationship whatsoever, all right? And so this is where an example of that correlation is great, but they did not cause each other to happen, okay? So correlation does not equal causation right there, okay? My ski resort making a butt ton of money has no impact on whether or not I'm going to die in the bed. All right? Go to lunch. When we get back, we'll practice.